Hello, hello, and welcome to Iron Riddle, a show where we discuss this. Well, I mean, discuss. Discuss is not the word; it doesn't do justice. Where we dissect this exciting new database implemented in Zeek called Target, where we look at every layer, at everything, at storage, at consensus, at caching, at the state machine, at testing, and try to understand how you could build something like this. Because the secret is actually systems programming is not hard. Systems programming is easy. You just have to iterate simple programming over a couple of years, and you could build a database, you could build a compiler, you could build anything. So, where are we at? Well, if you recall, the last few days, what we've been doing is looking at our deterministic simulation testing framework, at our Whopper. And we've looked at a bunch of things. We looked at the overall event loop, we looked, and we actually refactored it. We looked at fault injection, we looked at state checkers, and today I was going to look at workload and audit. But I decided to spice things up somewhat and actually switch to something completely different. So let's actually completely forget about the Whopper, no Whopper today at all. Instead, we'll be looking at this pull request. We actually will be just doing code review because, I mean, you always need to be proactive. So far, we've been reviewing code which is already written in Target, but today I decided that we might as well start reviewing pull requests. And, well, I mean, let's even go and review a draft pull request even before it is officially ready for review. Also, it is like super hot here in Portugal, so maybe it's just that my brain is melted. Okay, so what does this pull request do? It introduces the targetable recover subcommand to deal with the problem of replica dying permanently. So let's draw some diagrams here. We have our cluster, which in the typical deployment is 6 replicas. And the model is that replicas are resilient, replicas are robust. If a replica dies and then restarts, and maybe it even loses some data to shared writes, and maybe it even loses some data to localized disk corruption, the replica is able to quickly rejoin the cluster and resume the work. And we've seen how this works in our Replica protocol, where replicas can request individual prepares if they missed on the write-ahead lock, or if the replica was out of the cluster for too long. We've also seen the so-called sync protocol, where a replica can kind of like jump across time to the most recent state. And this is a good pair of protocols for the cases where replica temporarily becomes unavailable, but then comes back to life. So if our picture looks like this, then the recovery and the state sync protocol works correctly. However, there is, very reasonable failure mode is that the replica is lost completely. Like, I don't know. No, what happened here? Like, I just want to, no, I definitely don't want to send any kind of, okay, let's this just this way. So, replica is completely gone. Like, the entire data center burned down. There was a lightning bolt which struck a poor computer, or some such thing which caused the replica to be permanently unavailable. It is done. It is destroyed completely. It is not in this world anymore. So how would we and okay, let's number the replicas. So this is 1, this is 2, this is 3. The GAN one is 4, so this is 5, and this is 6. So what do we do here? Well, like, somehow you need to introduce a new replica into the cluster. You need to, well, yes, create a new data file and say, hey, you are the new replica number 4. And that's actually tricky. It sounds like it is simple. So what if we do and just create a fresh data file? So let's say that each of the replicas had some amount of data stored. Maybe some replicas have a little bit more data, and some have like just a tiny little amount of data because they were partition from a cluster. So what if we actually go and introduce a fresh replica, which is number 4? What could go wrong? Well, one thing which could go terribly wrong is if you duplicate a replica by accident. So if actually you introduce a new replica number 4, but there's already an existing replica number 4. So if that is the case, then yeah, that's kind of like immediately data loss, immediately split brain, because each replica thinks that there is only one instance of it globally, and if there is 2, then too bad. But let's assume that you actually are positively sure. Okay, why? Okay, yeah, that's better. Just quit. So let's say you're positively sure that the computer is fully gone. Like, you saw the shards of its hard drive yourself. Like, it cannot possibly be alive. So is it safe to just then introduce a fresh empty replica and claim that it is replica number 4? Well, not really. Consider this case. So let's say that we have normally functioning cluster, and the cluster is partitioned. And let's say replica number 5 is a primary. And let's say that replica number 5 decides to commit op number 10. I want new one. So we have op number 10 on the primary, and then primary sends this to 6 and sends this to 4, and then they reply with prepare OKs. And obviously, the primary has its own prepare OK, so it considered that op number 10 is committed. Okay, so this happens. Like this, half of the cluster is isolated, but due to flexible quorums, the half with the primary can continue processing requests. And that thing could actually go and commit op number 10. Now, what happens is that before the partition is fixed, our replica number 4 dies. And then we introduce a fresh copy of it, which haven't heard about op number 10. And the partition is now looking like this. So we have 4 replicas in here. Neither of those 4 replicas knows about the existence of op number 10. Although replica number 4 accepted the op number 10 before, we completely replaced it with a fresh empty replica. So now, if now we have quorum here, so we could select a new primary. And the primary will need to figure out what is commit max. And because none of those folks have even heard about op number 10, the actual commit max that replica number 2 will learn is going to be 9. So it will prepare, okay, let's change this to red, okay. So it will prepare a different version of op number 10, and then that version of the different version of op number 10 could actually get committed. And I mean, that would be the most horrible thing ever to happen for our database, because that means that we committed contradictory operations. We have 2 versions of op number 10 committed. So you cannot really do this. You need to do something smarter to introduce a replica into a cluster after a replica crashed completely. So how could we do this? Well, the fully general solution here is the so-called reconfiguration protocol, which allows you to arbitrarily change cluster membership. And okay, this is like embarrassing, because one of my first tasks when I joined Targetbiddle was to do a reconfiguration protocol, and I kind of like spent half a year on that, and that was like too hard, and I implemented like 10% of that, and then kind of like just gave up. So that's like still not done. Yeah, like if we had reconfiguration, this thing would have been easy, but well, because of me, we don't have reconfiguration. Sorry, DG. But there is like this crucial simplifying assumption, which allows us to implement this replica, single replica replacement without going all the way to full reconfiguration protocol. And that is this. The tricky part about reconfiguration is that it bootstraps itself. Kind of like the cluster essentially needs to decide itself who is a member of the cluster and who is not. And this is where all the algorithmic complexity of reconfiguration comes in. There is a very simple approach to reconfiguration, which relies on an external consensus. If you have some other consensus, you could use that as a source of truth on the information about who is part of a cluster. And this is essentially what we are going to do here, because the crucial element, the simplifying element, is that we rely on the operator to guarantee that the old version of the replica is completely gone, and that when we start a new version of replica number 4 with an empty data file, the old, there can't be the old one anymore. So that's kind of like the part where we make a human operator a part of this external consensus. And of course, if, just, could you please shut up? And if the human operator messes things up, they could lose data. But well, hopefully they are careful enough, because you could go only so far protecting from operator mistakes. At the end of the day, you should still be careful when you are operating on real-world deployed databases. Okay, so without further ado, let's see what is the approach in this pull request. Okay, no, I actually want to do this, make this bigger, not smaller. Okay, so the basic idea is that we have a new target recover command, which is like, just, could you okay, let me, no, I don't want to choose it. Okay, now it is, hopefully now it is final again. Sorry about that. Yeah, so target recover is like target format. It goes and creates an empty data file, but it assumes that the cluster is already there and that the previous incarnation of the replica is dead. So it's specifically geared towards this recovery protocol. So how do we do this? Well, it says that we start by sending a bunch of requests to the cluster. Presumably, what this allows for is that it allows us to guarantee that the journal of the replica which we are trying to replace is no longer relevant. Because, why do we even need the replica? Why its data is so important? Well, one part is that it has a journal. So this replica in the past might have received a prepare and replied with a prepare okay to this preparer, that way guaranteeing that, hey, I had this prepare. And if we install a new version of this replica in the cluster, and this new version doesn't have this prepare, then we kind of violate this guarantee, and in effect could and that could lead to the data loss. So we need to make sure that the highest prepare that could have been in the previous replica's write-ahead log is already committed. So we need to guarantee that the commit mean is higher than whatever was in the recovering replica log. Okay, so that is this part. Now, after we are sure that we cannot actively lose the data, we format the data file and we stamp it with a higher view. This is this part is funny. So I think if we do just number one, it will be correct in a sense that it wouldn't cause the data loss, but it still could cause some internal assertions where replicas receive contradictory messages from the old and the new version of replaced replica, assuming that the network, delays messages significantly. So we want to avoid that. And for that, we actually want to also move the new replica into a view which is higher than any view before. And that's why we increment view by 2. Okay, so immediately I'm kind of curious, oh dear, I'm being rated at. Thank you, Laris, but sorry, this is the worst possible moment for a raid because we are again discussing consensus. So this is super tricky and no one will understand anything. But if you still want to try, basically the idea of what we are talking about right now is that we are solving a problem where in a cluster of 6 replicas in a distributed database, 1 replica died completely, and we want to replace it with a fresh copy. And we want to make sure that this fresh copy would not cause a data loss by essentially forgetting about the data that the previous incantation of this replica acknowledged. Okay, and that's how we are going to do that. First of all, we'll force the cluster to commit a bunch of prepares to make sure that it is way ahead of the state the cluster was when the replaced replica crashed. And then we make sure that the replaced replica starts in a view higher than it has. That should be safe. Okay, so let's see how do we do code review. Because actually, what I really want to do is I want to show how I do code reviews, because I think that might be helpful. Because this is not a workflow I originally started with. This is something actually I read it. So okay, we want to review pull request. Normally, when you want to check out pull request manual on the command line, you do GitHub pull request checkout something. But I actually have my own script for that because I don't like how GitHub PR creates a branch. I don't want a branch, I just want to check out the pull request. So I had my own script. And that just goes and checks out pull request. But also, for code review, I really okay, so we are on the branch, but we actually don't know what are the changes from the pull request and what are the new changes. So in my version, I also have this review flag, which specifically checkouts pull request for code review. And you see that after I do this, I actually have a bunch of untracked changes there. And this is because the way review works is that it checkouts this commit, but then resets it to the merge base. So presumably put the dev in dev hub is the merge base. And well, I mean, we've lost, I mean, I think we can log from here. Yeah, there's a bunch of pull requests here. Okay, yeah. So yeah, you see, we reset from this commit, but the changes are there. It was, I think it's called like a mixed reset. I always forget those flags. Okay, so why is that? Well, now if I open my editor and I open my Git integration, I actually see the diff. I see all the files that were changed. And I can quickly navigate to them and see what's going on there. Okay, so let's see. Shall we quickly check out the docs? Okay, we have a new entry. Okay, this is embarrassing. This should work. Okay, yeah. Okay, if the replica data file is permanently lost, okay, and let's actually start adding comments here. Do you wrap these at 80 at this pure style? Okay, if a replica data file is permanently lost, for example, XSD, then a new replica must be formatted to restore the cluster. The tag format must not be used for this purpose. Instead, okay, explain why it must not be used data. See below. Note that tag requires the cluster to be healthy and capable of view changing. Once the individual recovery succeeds, runtime will start as normal. At this point, the new replica will rejoin the cluster and state sync to repair itself. Example, console. Take to recover, cluster, addresses, replica, replica count, and the name of the data file. Okay. Okay, yeah. Looks reasonable. Okay, so the docs are good. And I mean, we've just reviewed this file and this file. So we could stage that in our editor, and actually that's going to be our review. Actually, I mean, why okay, let's keep it. I was thinking that maybe we should even commit, but okay, stage file. Okay, now how do we continue viewing this pull request? And this is okay. This is something which frustrates me a lot about doing code reviews, in that when you are writing the change, you are writing it in a certain logical order. You have a linear story in your head, like, hey, we do this, and that. But when you actually write it, well, you see it's like, I don't know how many lines changed, like 20 something files changed, which is like ridiculous. And it's super hard to like figure out where is the beginning of the story, because if you like jump in the middle of the change, like, okay, let's say I'm fast view equals now, like, you know, it's not the beginning of the story. So where is the beginning? I don't know, but a good thing is to start with the interfaces. So go from the outside in. And this is like Tagabil is a CLI application. So the start is, of course, in the CLI. And let's see where we are at. And again, so you see, like how I'm using staging to review pull requests efficiently. First of all, of course, I'm using my editor's built-in Git view to see and stage changes, so I could see what has changed there. But also here, I have a special command to go to the next change. So I have this bound to C. So if I want to jump between changes in a single file, I mean, I can use my standard editor shortcut for navigate, and it's like so much better than, like, you know, your GitHub's default web view. Okay, so we have recover, which takes cluster addresses, replica count development. But why replica is nullable? that feels very strange. How do I? Okay. Why is this? No, I expect replica to be mandatory. Okay. Path. Okay, yeah, that looks fine. Oh, okay. I think. Well, help us below. Recover cluster addresses, replica index, replica. Let's double check this cluster addresses. Replica count, development. Development flag also feels like strange here. Oh, actually no. I think that's fine. Like development basically starts database with reduced runtime parameters so that it doesn't use as much RAM, but also is obviously like much slower, which I think is actually fine for testing and recovery. Okay. Recover. Create a targetable replica data file at path for recovery. Used when the replica data file is completely lost. Replica must sync before they can participate in consensus. Okay, yeah, that makes sense. Makes sense. Makes sense. Okay, so CLI makes sense to me. Also, I mean, this is why I love Maker. So you see the problem. I have a bunch of files, and I want to stage the file which is called CLI. Like, how do I do it? I mean, I can like scan this list visually, but I mean, I've spent like 10 seconds doing that and didn't find it. Well, I mean, maybe because I just don't know the order of letters in the English alphabet. But I could just use my standard editor's functionality like textual search to find the file I want to stage. That is the power of text interfaces. And I mean, I want to emphasize that like the fact that like Emacs is a Lisp machine is not really the key. I mean, this code is not a Lisp machine. I mean, it's like TypeScript, which is not Lisp, and what's more, it is kind of like completely closed system. You cannot extend this code in the same way you could extend the Emacs, because Emacs is like truly malleable. You could modify everything. In this code, you could only extend certain extension points. But the thing is, you could still do this text-centric user interfaces. And this is like so powerful. Text is so much better than GUI for interfaces. And when I say text, I don't think the terminal. You see, I don't use terminal for Git. I use like this thing, because I do want like, text buffer, like the 2D text, not the like stream, which is like stream is great for like batch processing, but it's pretty horrible for interactivity. Okay, so let's go and see what do we do in main. So we have client, we have replica format. Okay, this. Okay, this is okay. So probably replica format type is what's going to be the main need here. Okay, we format and we pass view equal now, which makes sense. recover or reformat. Why is it called reformat and not recover in the code? Well, is this? Yeah, reform. Okay, well, it's probably it makes sense that the public name for this functionality is recover, but the internal name is reformat. Okay, let's make a mental note of that. What changed here? Okay, I don't understand this. So we had storage and storage size limit. Oh, okay, it's just it was just reformatted, and well, we also removed superblock somehow. Okay, that doesn't make sense. Superblock. Oh, yeah, okay, right. Because before we actually needed a superblock for formatted, and now we do that. Okay, yeah, that makes sense. That's actually a nice simplification. Okay, reformat. So we take this recover command, which I think is what we've seen before. Yeah, that's same thing. Cluster address replica count pub development. The initialize command. The initialize command create message pool for the client, because remember, we want to send a bunch of requests to make sure that the state of the cluster is ahead of the state of the replica, and for that we need a client. Okay, crypto. I think this is better spelled as, where is my mind? Okay, yeah, this is how it's called. But why doesn't this work? What broke there? Okay, can we actually build this code? I don't get. It builds. I don't get why I'm not getting code completion from ZLS here. But well, who needs code completion, right? I would never waste my time implementing code completion for some language. Okay, so we create a client, and then we create our reformatter. And we the reformatter. Okay, that seems pretty reasonable. Okay, anything else here? Well, no. That was all right. You see, I did it again. Like I really need this ability to just search in the list of files like this kind of like really really what I find useful about text-based interfaces. Okay, so where shall we go next? Well, so I think like reformatter init, start, and status is where it is at. So let's see. Replica reformat. Okay, replica recovered. Format the data file to replace one which was permanently lost. The recovery process sends pipeline max requests when register pulls many no ops to the cluster. Once those have committed, creates a new data file. Data file in its okay, so here I want to say explain why I need to send the requests and why pipeline prepare max max is enough. Ditto for the view number. Okay. Some standard boilerplate for defining generic struct. Result. Yeah, like communicating. Asynchronously is hard. Okay, so I need to type comma into the source field. This is something I cannot do, sadly. Oh, okay. Do we use status? Call this thing. Okay. Status to be client. Consistency is important. Okay. Allocator. Okay, so this one smells like we shouldn't be we shouldn't be storing allocator in the field. That's kind of like goes against our only allocated a startup, which again, I mean, for reformat command, maybe this is fine, but well, let's see if there is some better way to get rid of it. It is shorter and gives more information to the reader. Let's call the floor free arena. Does it need to call free? Okay. Indeed. Oh, this is getting curious and curious. So we have an allocator, we have deinit, but deinit doesn't do anything. Well, I mean, our init doesn't do anything, So maybe the init shouldn't, but then why do we need to like, status result? Okay, start. Maybe call it done. No, which is better, just an option. Okay, start. Okay, we register. And then register result, batch size limit. Okay, yeah, we indeed should be user data. Okay, format requests. Then and client request. Okay, so what we want to do is like pipeline things of requests. We assert that. Okay, there shouldn't be any need for an int cast here. Like, I mean, size of its compile time int, it's like already int casted to whatever you need it. User data. Okay. Should we apply that this part here? Maybe not. I don't know. Well, let's do this for consistency. So we do it elsewhere. Consistency is a goblin of small minds, and I'm not claiming that my mind is particularly large. Well, foolish consistency, but I'm not claiming my consistency is particularly smart either. Okay. Client request callback. Okay, view, since we might have sent the VC part +1 before we crashed. Format as client request. Okay, and then we do format. And format is presumably our usual format, except that we set the view to what we want it to be. Okay. Result success. Okay. not a fan of this writing result over here. Can we maybe return from this callback and require the caller to call format, and maybe even hide the event loop inside replica format type. The format method is blocking. So we might make the thing blocking as well. Something like this. Main zip. Reformatter. Reformat. Replica. Zeke. Then format. While how do we do this in the format? Because we do have this this while self sending requests self run format void. Okay, there's a comment in chat. To be honest, I never get the logic of calling allocator, GPA, arena, etc. Isn't it then just a leak abstraction? Of course, it seems that going all the way and just using the unmanaged style on real methods is the best. I don't know. Yeah, well, I mean, it is a leak abstraction, but that is the thing. The reason why you are using an arena, or one of the reasons why you're using an arena, is that you don't want the code for deallocation to end up in your binary. So imagine, imagine you have something which is an array list of strings. Now, if you are writing this code against a generic allocator, then you need to defer, and in that defer, you need to iterate over this array list of strings and free each individual string, and then you need to free the entire array list. This is like not trivial amount of code. And one of the ideas behind of the arena is that you don't have to write that kind of thing, because the cleanup happens once and for all the objects simultaneously when the entire arena is closed. But I mean, that means that if you are writing the code which kind of like maintains this construction, this array list of strings, well, you want to know whether your allocator is arena or not. Because if you know that it is arena, you actually do want to omit that code for like dropping things. I mean, well, you could say that, hey, actually, I mean, I don't know, and you still write the defer code, but if you don't know and you don't actually check that, it probably is going to be buggy, it's going to be leaky, and chances are the compiler wouldn't be able to fully eliminate that loop, because, well, it actually like does some side effects and things to the arena. So like you can treat your code fully abstract, but you don't have to. And if you know that something is an arena, you could simplify your life a lot. But then if you do make an assumption that something is an arena, then you have to actually document your assumption. And the best way to document your assumption is actually just to call the variable arena. And well, kind of like GPA means that, hey, actually, like, yeah, this is like fully general purpose allocator. Okay, so hopefully that answers this question. Well, but actually, okay, this reminds me. We never looked at like who uses the allocator. Okay, reformatting uses the allocator. Okay, that's why we need to store this thing. Okay, yeah. So let's actually go. Another side effect of that is that you wouldn't have to store allocator as a field and alarm a rising pattern for us. It is right to store the allocator as we do here, but it is still surprising. Surprised, because I am surprised. You see, like, I mean, I immediately like stumbled upon that line. Surprised, not glad from this tree. Okay. Huh, but that's actually, I mean, that's actually pretty tame. Okay. I mean, I'm happy. I was fearing that it's going to be super hard. Okay, I think that's actually kind of like covers most of it. Like, really, probably there's going to be a bunch of whopper changes. And I'm curious, like, what are the rest of the changes? So reformat end. Okay, yep. Then visa operation. Okay, this is some just some boring formatting checks. So this is for format, right? Yeah, format. We gain this thing. Okay. Okay, this is testing. So testing would need some longer review. Okay, this is also something on trivial. So okay, you see, I guess I should explain what I've done. So I feel like we've like, you know, we had this like huge diff. I think we've cut through like the bone of it. We like now we like fully understand the flow. But we still haven't reviewed all the files. Now, what I want to do is kind of like do the opposite. Find all the trivial changes, look at them, and just approve them, because I mean, trivial changes is fine. Okay, no op clients. Okay, why do we okay, yeah, this makes sense. And here we do want to say that this is, yeah, okay, yeah, we don't want to um, um, we don't want to make like the stuff variable parameterized by the state machine. So okay, this actually, I mean, this I really love this change. This is so good. Okay. What is this? Okay, yeah, that makes sense. Removing default is always good. We do have reconfigure request. We just I hate every time when they see this like half finished configuration written, well, not written by myself. Okay. Um, okay. Huh. Super tiny changed the replica. Okay. View. Okay, this also makes sense. Okay, so let's see what's left here. Okay, actually, we are at an hour, and I'm not really keen on going and reviewing the tests right now because, as I've said, it's like horribly hot in Portugal, and my mind is like completely fried at this point, both like metaphorically and physically. So I guess let's actually pause here. I hope that was a useful episode where we learned both how to use your editor to do code reviews without like relying on GitHub, and also, I mean, it's not because we don't want to rely on GitHub. I mean, I would be happy to rely on GitHub if their code review was actually, I mean, as good as my editor, but it just isn't. So that's the reason. And also how, like, why the process of restoring a fully crashed replica from a cluster is hard, and how you could do that without coding the entirety of reconfiguration. Yeah, I guess that's it for today. Please join me next time at 5 p.m. UTC live on Twitch, and well, sometime afterwards in the recording on YouTube. And next week, I think we'll resume our journey into the gods of the Whopper. Okay, goodbye, folks.